Okay, hello again. This video goes with page 2 of your notes. Again, you can always look at the physics classroom lessons to get some more detail on these lessons. What we want to focus on here is two things. I want you to understand that a vector can be resolved into its x and y components. And this is something that can be done both graphically, that is through a picture, and also by trigonometry, that is through math. So what does it mean to say that you can resolve a vector? That means it means that you're breaking it into its pieces. Okay? So when you say resolved, you mean broken into pieces. And so components are just another word for pieces. So as an example, let's say that we have this vector. Let's call this a velocity vector. And the velocity vector starts down here, and it points kind of in the northeast direction. We would say that that velocity vector can be resolved into an x piece and a y piece. That is a horizontal piece and a vertical piece. So there would be a horizontal piece which basically goes along the horizontal direction. In other words, in the x direction. And there's also a vertical piece which goes in the vertical direction. That is, which goes straight up. And so these pieces are actually can be thought of as the two things that you would kind of add together to get the vector. Vectors in two dimensions can always be broken down into these pieces. And so this is what we mean by resolving them. Okay? So when you sketch it graphically, you would sketch the pieces just like I did right here. Okay? So to resolve this vector, this diagonal vector, into its x piece, basically means drawing a box around the vector and then extending a vector along the horizontal edge of that box. That's the x component. The y component would be drawing a new vector along here, the vertical direction. Sometimes people could also draw this vector on that side, and they would say, well, that's the y component, and that's also correct. Remember, vectors can be pushed around. We mentioned that in the other lesson. So any vector that's pointing upwards that has that length would be the component, the y component of the original vector. Okay. From a trigonometry point of view, you can also find components, and that means we would have to solve for these values of Vx and Vy, figure out how big they are. Of course, we need to know the angle that the original vector makes, and we would need to know the magnitude of this vector, how big is the velocity vector that we're starting with. And so the way that we would determine that would be to say that Vx is going to be equal to V times the cosine of the angle, and Vy is equal to V times the sine of the same angle. And that allows you to find the pieces. So for example, if you had, we'll do an example to the side here. Let's say that the vector is 100 units long, and let's say that the angle is 30 degrees. Okay? So you would say that you'd have an x component that points to the right, and you would have a y component which points up. In this example, the Vx would be equal to 100 times the cosine of 30, and hopefully you remember cos 30 is 0.86, so this is going to be 86, I don't know, maybe meters per second if this is velocity. So again, if this is an airplane and the airplane is flying at 100 meters per second in this direction, that means that it's flying at 86 meters per second to the right. We now know the number. If you look at the y component would be 100 times the sine of 30. Of course, the sine of 30 is a half, so this would be 50 meters per second. So that means that this airplane would be going vertically upwards at 50 meters per second. And so these components have a meaning, and they're telling you how fast is the velocity, horizontally, and what is the velocity vertically. What if you want to go the other way? So in other words, what if you know what the components are, but you want to figure out what the original vector is? So let's say that I knew that I had 86 meters per second as my horizontal component, and let's say that I knew that my vertical component was 50 meters per second. How do I find the the value of the velocity? How do I find the angle? And the answer is that to find the value up here of the velocity, I would use the Pythagorean theorem. And to find the angle, I would use the inverse tangent. And I'm assuming you guys know this already, but really quickly, let's just apply this. So by the Pythagorean theorem, I would say that v squared equals vx squared plus vy squared. So that means that v is equal to the square root of 86 squared plus 50 squared. And if you do that on your calculator, I think you could test this and find out that that's going to be 100 meters per second. So that's the Pythagorean theorem. And if you want to find the angle here, you would find the angle by saying that theta is equal to the inverse tangent of opposite over adjacent. And so you need to know what opposite and adjacent are. Opposite is 50, adjacent is 86. So we're talking about inverse tangent of 50 over 86. And of course, that's going to give us our angle of 30 degrees, or close to it. So you might want to practice with that a little bit, but you need to always identify opposite and adjacent correctly. Now, notice if you make this your angle, that it's going to be different. In this case, to find the angle, the opposite side would be 86, and the adjacent would be 50, okay? Because there's your opposite, here's your adjacent, and the angle that you're going to get in this case is actually going to be 60 degrees, and of course 60 and 30 add up to 90. So, be really careful about where the angle is, because the angle is not always in this position. All right, so that would be that. So hopefully we've shown here how to find components graphically by sketching them, algebraically by trigging them, and we've shown how to find the magnitude and angle of the original vector if you know the components.